Good morning everyone. Decimal representation of a rational number. Let our rational number be of the form P upon Q. Then when P is divided by Q, we have two types of decimal. Either it terminates after a few steps. Terminating decimal. Terminating decimal means we will get a remainder as 0 after finite number of steps. Another thing is we get a repeating set of decimals. We do not get the remainder 0 but repeating set of decimals. Repeating set of decimals means suppose let our decimal number will be 2.17171717 and so on. Here 17 is being repeated. That means we can write it as 2.17. That means to conclude, when P is divided by Q, either we get a terminating decimal, that means remainder is 0, or we get a repeating set of decimals, for example 2.17171717 and so on. It will never terminate. So it will be 2.17. We will put a bar for the repeating decimal. Now let us understand what is terminating decimals. Terminating decimals. Let us take a rational number 1 upon 4. That means 1 is to be divided by 4. Let us divide 1 by 4. 1 by 4. I write 0 here. 2's are 8. 2. 1 more 0. 5 times 20. I get a remainder 0. This is a terminating decimal. 0.25. Let us take one more example. 2, 3 upon 5. Which is equal to 13 upon 5. 2's are 10, 3, 0, 0.6, 30. See, we got the remainder 0. This is 2.6. This is terminating decimal. Now, what do we know that? Whenever we obtain a terminating decimal, here prime factors of Q are either 2 or 5. That means there is no other prime factor other than 2 and 5. I repeat, Q should not have any other prime factor other than 2 and 5. Then we obtain a terminating decimal. Now let us solve few questions related to this. Let us find whether these are terminating decimals or not. 5 upon 12, 11 upon 24. Now see, 5 upon, I can write 5 upon 32. 5 upon 32 is 5 upon 2 raised to power 5. Here, Q the factors are, prime factors are 2. That means it is a terminating decimal. For 24, I can write it as 3 multiplied to 8. 3 multiplied to 8 can also be written as 2Q multiplied to 3. Which is, the prime factor is also 3. Other than 2 and 5, so my answer is no, it is not a terminating decimal. Okay, what are repeating or recurring decimal? When the block of decimals are repeated. This is called repeating or also recurring decimals. Now let us take the example 2 upon 3. Let us start the division. 2 divided by 3. 0, I get 0.6 are 18. Again 2, 0, 6 are 18. Again 2, 0, 6 times 18. We notice that this will keep on continuing. 6 will keep on repeating. So it is called as repeating or recurring decimal. It can be written as 0.6. One more example. 3/11. Let us divide 3 by 11. I get 0 here, I get decimal, 2s are 22, 8, 0, 7s are 77, 3, 0, 2s are 22, 7, 0, I get 7 times and so on. We see that this will continue. So 0.27 is the answer. One more example. 15/7. Let us divide 15 by 7. 2s are 14. 28. We are not, till now we are not getting anything repeated. Now again 1s are 7. We see that this will repeat now from 10, 7 and so on. We see that we get this as 2.142857 is being repeated. If we see that there are 6 digits in the number, wherever the numbers that are repeated are 6 digit, this is called length of the string. Another important thing, the length of the string is always n minus 1. That means if this is 7, maximum is n minus 1. It can be less than that, but not more than that. See, if this is 7, the maximum length of the string that we can obtain is 7 minus 1, 6, as in this case. That is the maximum length of the string that can be obtained. Now, special characteristic of rational numbers. This is, first of all, rational numbers in the decimal form, that it is terminating, either they are terminating decimals or repeating decimals. This is the special characteristics of the rational decimals. Number obtained in the decimal, rational number written in the decimal form. Express 0.3 in the form P upon Q. Let x equal to 0.333 and so on. Then 10x is equal to 3.333 and so on. Let this be the first one equation, this be the second equation. Subtract 1 from 2. What do we get? 10x minus x, which is 9x, equal to 3. X is equal to 3 upon 9, which is equal to 1 upon 3. One more question. Let us express 1.4 in the fraction form or P upon Q form. Here x is equal to 1.444 and so on. 10x is equal to 14.444. Again, subtract 1 from 2. What do we get this as? 9x equal to 13.00. X is equal to 13 upon 9. Let us express x equal to 0.001001 and so on in the rational form. Here the three numbers are being repeated. So we are going to multiply it by 1000. 1000x equal to 1.001, 001, 001 and so on. This is 1, this is 2. Subtracting 1 from 2, we will get 999x equal to 1. X is equal to